Imagine a warship so massive that it can carry an entire air force across the world's oceans. A vessel so powerful that its arrival alone can alter the political calculations of entire nations. For decades, aircraft carriers have been the ultimate symbol of American military dominance, allowing the United States to project power anywhere on Earth without relying on foreign bases. But even among these floating giants, one class stands above all others: the Gerald R. Ford-class aircraft carrier. Named after the 38th President of the United States, Gerald R. Ford, this revolutionary class of supercarriers represents the most ambitious naval engineering project of the modern era. Built to replace the legendary Nimitz-class carriers that have dominated the seas since the Cold War, the Ford class is not merely an upgrade. It is a complete reimagining of what an aircraft carrier can be in the 21st century. To understand why the Gerald R. Ford is such a remarkable achievement, we first need to understand the role aircraft carriers play in modern warfare. Unlike battleships of the past, aircraft carriers do not rely on their own guns to destroy enemy forces. Instead, they serve as floating air bases capable of launching dozens of aircraft thousands of miles from home. Wherever a carrier strike group sails, it brings with it the ability to conduct air superiority missions, precision strikes, intelligence gathering, surveillance, reconnaissance, electronic warfare, humanitarian operations, and disaster relief. For more than 50 years, the Nimitz-class carriers fulfilled that mission with incredible success. These ships participated in nearly every major American military operation since the 1970s. They patrolled the Persian Gulf, supported operations in Afghanistan and Iraq, responded to international crises, and demonstrated American resolve during periods of global tension. Yet as technology evolved and new threats emerged, it became clear that even the mighty Nimitz-class would eventually need a successor. That successor arrived in the form of the Gerald R. Ford. At first glance, the Ford class resembles previous American carriers. It is an enormous floating city made of steel, stretching more than 1,100 feet from bow to stern. Its flight deck covers more than 4 acres of space, enough to support constant air operations around the clock. Displacing over 100,000 tons when fully loaded, the ship is among the largest warships ever built by any nation. Yet beneath the familiar appearance lies an entirely new generation of technology. The first thing that sets the Ford class apart is its revolutionary aircraft launch system. For decades, American carriers relied on steam catapults to launch aircraft from their decks. These systems worked well, but they were complex, maintenance-intensive, and limited by technology that had changed little since the middle of the 20th century. The Ford class replaces steam catapults with the electromagnetic aircraft launch system, better known as EMALS. Instead of using steam pressure, EMALS uses powerful electromagnetic forces to accelerate aircraft down the flight deck. This provides smoother launches, reduces stress on aircraft, and allows the carrier to launch a wider range of platforms, from heavy fighter jets to lightweight unmanned drones. The impact of this innovation cannot be overstated. In modern warfare, the number of aircraft a carrier can launch and recover each day directly affects its combat power. Every additional sortie means more bombs delivered, more reconnaissance missions flown, and more targets destroyed. Thanks to EMALS and numerous flight deck improvements, the Navy expects the Ford class to generate significantly more sorties than the Nimitz class. During sustained operations, the carrier can maintain an incredibly high operational tempo, ensuring that enemy forces remain under constant pressure. Picture a conflict in the Pacific. Hundreds of miles from the nearest friendly airfield, the Gerald R. Ford launches fighters before dawn. Within minutes, additional aircraft follow. Surveillance drones climb into the sky. Electronic warfare aircraft begin jamming enemy communications. Tankers refuel fighters in the air. Strike aircraft race toward distant targets. Hours later, another wave launches, followed by another and another. Day and night, the carrier continues producing combat power without pause. That ability to sustain operations is what makes aircraft carriers so valuable. The Ford class was also designed with the future in mind. Military planners understand that unmanned systems will play an increasingly important role in future conflicts. Drones are becoming larger, smarter, and more capable every year. Some will gather intelligence. Others will carry weapons. Some may even operate alongside human pilots as loyal wingmen. Unlike older carriers, the Ford-class was specifically designed to accommodate this transformation. Its launch and recovery systems can support a wide variety of unmanned aircraft, allowing the ship to adapt as drone technology evolves. In many ways, the Ford-class is not simply an aircraft carrier for today's wars. It is an aircraft carrier for wars that have not yet happened. Another area where the Ford-class dramatically surpasses its predecessor is power generation. The ship's 2 nuclear reactors produce significantly more electrical power than those found aboard the Nimitz-class. This extra capacity provides tremendous flexibility for future upgrades. Advanced sensors, electronic warfare equipment, and next-generation communication systems all require electricity. Future laser weapons capable of intercepting drones and missiles will require even more. Many military analysts believe directed energy weapons could eventually revolutionize naval warfare. Instead of firing expensive interceptor missiles, future warships may use concentrated beams of energy to destroy incoming threats almost instantly. While that future is still developing, the Ford-class was built with enough electrical capacity to make such technologies possible. Power alone, however, means little without efficiency. One of the greatest challenges aboard any aircraft carrier is managing the movement of weapons, fuel, aircraft parts, and personnel. Every bomb loaded onto an aircraft must travel through a complex network of elevators, storage areas, and preparation stations before reaching the flight deck. The Ford-class introduces advanced automated systems that streamline these processes. New weapons elevators use electromagnetic technology to move munitions more quickly and efficiently throughout the ship. Reduced reliance on manual labor accelerates operations while improving safety. In combat, seconds matter. Faster logistics mean more aircraft can be prepared and launched in less time. The ship's radar systems have undergone a similar transformation. Previous carriers relied on multiple radar systems to perform different functions. The Ford-class integrates many of these capabilities into advanced multifunction radar technology. This allows the ship to detect threats at greater distances, track multiple targets simultaneously, and provide superior situational awareness to commanders. Equally important is the redesign of the carrier's island structure. Engineers reduced its size and repositioned it to improve flight deck efficiency. While this may sound like a minor adjustment, every square foot on a carrier is valuable. The redesigned island allows aircraft to move more freely, reducing congestion and increasing operational effectiveness. Yet perhaps the most impressive aspect of the Ford-class is something most people never see: automation. Modern technology has allowed the Navy to reduce crew requirements significantly compared to previous carriers. Thousands of sailors still live and work aboard the ship, but advanced systems eliminate many labor-intensive tasks that once required large numbers of personnel. This offers multiple advantages. Fewer crew members mean lower operating costs. Less space is required for living quarters. Fewer supplies must be transported during deployments. Over the ship's projected 50-year lifespan, these efficiencies could save billions of dollars. And that matters because aircraft carriers are expensive. The construction cost of a Gerald R. Ford-class carrier exceeds $13 billion. Critics often point to this figure as evidence that carriers are becoming too costly. However, supporters argue that no other military asset can match their flexibility. A single carrier can conduct air operations without relying on foreign governments for permission. It can respond to crises within days. It can support military operations, provide humanitarian aid, evacuate civilians, and deter potential adversaries simply through its presence. In many ways, a carrier serves as both a weapon and a diplomatic tool. Of course, the Ford-class has not been without controversy. Its cutting-edge technologies encountered significant challenges during development. The EMALS launch system faced reliability concerns. New weapons elevators required extensive testing. Some systems took longer than expected to reach operational readiness. Costs increased, schedules slipped, and critics questioned whether the program had become too ambitious. Yet such challenges are not unusual for revolutionary military projects. Throughout history, many groundbreaking weapon systems experienced difficulties during development before eventually proving their worth. Today, the Gerald R. Ford is steadily demonstrating its capabilities during real-world deployments and exercises. As lessons are learned and improvements are implemented, confidence in the class continues to grow. Some enthusiasts even describe the Ford class as unsinkable. While no ship is truly immune to destruction, the reality is that these carriers are among the most survivable military platforms ever built. Their massive size, compartmentalized construction, advanced damage control systems, escorting destroyers, cruisers, submarines, and protective air wings create multiple layers of defense that few adversaries could overcome. Destroying a carrier strike group would require one of the most sophisticated military operations ever attempted. As the 21st century progresses, the oceans are becoming increasingly contested. Rising powers are expanding their naval capabilities. New missile technologies are challenging traditional assumptions about maritime warfare. Drones, cyber warfare, artificial intelligence, and space-based systems are reshaping the battlefield. Against this backdrop, the Gerald R. Ford class represents America's answer to the future. It combines immense firepower, unmatched mobility, advanced automation, enormous electrical capacity, and the flexibility to adapt to technologies that do not yet exist. More than just a replacement for the Nimitz-class, it is a bridge to the next era of naval warfare. Whether viewed as a floating fortress, a technological masterpiece, or the ultimate symbol of American sea power, one thing is clear. The Gerald R. Ford-class aircraft carrier is not simply the largest warship of its kind. It is a glimpse into the future of military dominance at sea. A future where power, technology, and global reach converge aboard one of the most formidable vessels ever built by mankind.